right, here we go. So we are going to be doing bash programming. So let's go ahead and just start from the beginning and kind of go from there. The main objectives to show you is going to be variables, user input, which by the way, I still want to show you user input in Python because technically I haven't shown it to you right using like the input function, but we'll go back to Python later. Let's do bash now. So we're going to do variables, user input, I guess echo would be output, if statements, but like we're going to do if statements the right way this time because there's a lot of weird things with if statements, like really weird things going on. And then we're going to do some looping and then some functions, and that's pretty much where I ended. That's more than enough. That'll take us quite a while. So, because I assume we're going to run into issues, even though I practice all of this. So, let's go ahead and just start with the most basic thing, which is going to be comments, right? The pound symbol, right? So this is a comment. Okay? So, moving on from there. The variable naming convention, I confirmed it is like C++ in the sense that it has to, the first character again has to be alpha. It cannot be numeric, so you can't start a variable with a number. It has to start with a letter, ASCII letter. Upper or lower case, no problem. The second character can be a number, so it can be alphanumeric, and you can start with an underscore. However, it is discouraged because that's usually a system variable. Okay, so as an example, I had a couple of variables, and here comes the first interesting thing that I kind of relearned about Python or Bash. So when you're assigning variables, if you want to store a string, you can just do something like var equals 1 or var 1 equals, and then you can say like this is a string. Okay, what this is going to do is, if we go ahead and echo that. So echo is going to be how you print things to the screen. So that's your std out. So let's just do echo. Let's start with 1. So if we go ahead and run this again, if you don't have this set up as an executable, which you can see by doing the ls-a or sorry -l, you know, in this case it is already has an x as executable. But if it was not, then you can do the chmod like 777, or you can do the +x, either or. We'll talk about more about those later. I keep wanting to talk about them, but we will get to them. But yeah, in this case it's executable, so you do the // in front of it, and so you can see that this prints out a string. Okay. However, what if you want to put spaces in your string? You will see that this will not work. It will cross a problem. So, and by the way, this to me, you know, coming from C++ or Python, this looks like a variable, but it's not. It's actual string. Okay. So, what if I want to put spaces in my string? Well, to do that, I can use single or double quotes. However, there is a difference. So here comes the first kind of weird thing about this. So this string here has spaces. Okay? And I could also do something like this that says like, the string also has spaces. And both of these are going to work. However, they're different. They have different usages. In this case, they happen to kind of both work, but we're going to discover the differences in a minute here, okay? So you can see both of them work fine. However, if this one had a space, would not work fine, okay? So, what if I want to output or to store in a variable, first of all? What if I want to take what the content of a variable and then add it to another variable, okay? As part of the string. So let's say that I want to take this string and then print it out after this. Well, what can I do? Whenever I want to output a string, output a variable, I use a $sign to refer to it. So I don't just go out and say something like, I can't just go and say like echo bar 1. That will cause problems. That's why I keep putting the $signs here. Okay? So if I want to do that with a string, well, what I can do is I can put the $sign and I can put the variable. So let's say it's bar 1. And that'll work fine. See that? So we get the string that's in bar 3, and then we also get the bar 1 string. However, If I try this with the single quotes, it's not going to work. It's just going to print out $1. So therein lies the difference between single quotes and double quotes, or random rows, double quote there, but you know, it would have printed out the same. In that with single quotes, it's just printing out, it's just a string with spaces, but it's just a string. If you want to combine the string with variables and other things, you have to use a double quotes, and then the whole $ variable name will work. Okay, so that's the first thing that is kind of important to remember. I guess if you really don't want to remember it, this is kind of like your coverall. This will work for all scenarios, because even in this scenario, suppose you wanted to print out a $. You guys all remember in other programming languages, even in Discord, what's the escape sequence character? It's the \. So if I really want to print out bar1, all I got to do is put that \. If I call it again, you can see it prints out. Okay? So, yes, if you really don't want to remember how the single quote weirdness works, and just go with double quotes, and just remember that if you need to print out a special character, you can use the escape sequence, which is \. Here's pop question now. How do you print a \/ out then, if it's the escape sequence? So what if I want to print out a \/ in this string? That's right, 2 backslashes, yes. The escape sequence of the \ is another \. So yes, 2 backslashes. Or in this case, I put 3 because one of them is for the $. Yet again, the same thing. Try it out on Discord. That's the same. It's the same escape sequence actually. So that's kind of cool. So for the first time that I saw that, like if you want to print out, you know, in Discord the text, you do the 3 hats, or whatever we call that character. But if you want to print them out, then you do backslashes. If you want to print it a \, you do 2 backslashes. So yeah. All right. So again, the easiest thing is to go with the double quotes. Just remember how to use your escape sequences. Or if you want to be fancy, you can use the single quotes and be the right thing. Okay. So again, what will not work is if I tried something like this, where I actually want to print out the var, because again, it doesn't detect the $ as being a special thing, because it's single quotes. Okay, so that's just your printing. And by the way, I'm gonna keep deleting things so that the output doesn't grow. But I have a copy of this I can share with all of you later if you want. Just remind me. Okay. So moving on, the next thing is how do we store something from the terminal into a variable? So like in the terminal, you know, I can go ahead and type a command like pwd to get the directory. So suppose that I want to take this and store in a variable. The way you do that is you're going to use the equal sign. And by the way, be careful. I didn't kind of point this out, but like when I was declaring my variables and assigning them, you can't have spaces. If you have spaces, bad things happen. Like this will work, but the moment that I put a space in here, it all gets confused because it thinks that bar1's actually a command and bad things happen, okay? So don't put spaces. In other scenarios, you will have to put spaces, but not in this scenario, okay? So suppose that I want to store the output of a command into a variable. What do? I use parentheses in combination of the $, and inside of them, I can put whatever command I want. So like I can put pwd, and then I can echo this so we can see what's stored in there. I will probably, throughout the course of the day, forget to put this $, once in a while. Just there on there, it's kind of annoying. But as you can see, it does print out just the contents of that. If you want to make it more fancy to see it better, you can see like, this is what is in bar 5. And then this type, right? Oh, I am literally running pwd. There we go. This is what is in bar 5. So you can see there the contents of that. Okay? So that is how you store the commands of this. Now, this is just a single command, but I could most certainly go ahead and do piping or like a super complicated command in there, a sequence of commands. We'll do that a little bit later, but what I'm trying to get to is that this could be anything, okay? Anything that would run otherwise in the terminal. Heck, you could probably put in there another script, and I'm sure that it might work. So there I put in ls, so it actually stored a bunch of things in there. So that's that. Next, let's talk about command line arguments. So I think I might have shown you this the other day too, but there's one that I didn't know, and it's that one. So when you want to print out the command line arguments, what you do is you basically, they're going to be by default the $sign next to a number. Again, this is probably the reason why you can't declare variables that start with a number, because this is kind of reserved for this sort of scenario, and the parser will probably get confused with the interpreter. But if I go ahead and run this with some command line arguments here, we can see that the first thing that prints out will be the number of arguments, which is 3. It's not counting the program name as an argument, so that's why you're getting 3 there. It's kind of not traditional compared to C++ or Python. And then you can just go out and print them out. So $0 is going to be the name of your program or script, and then $1 is going to be the first one. So that's the A1 and then A2. And you can see that technically there is no A4, but the program didn't crash or create any errors. So that's, I guess, one good thing for Bash, that you don't get any nasty errors when you try to access arguments that don't exist. Do this in Python or C++. C++ you'll crash. Python you'll get a traceback error probably. So that's, I guess, the only good thing of Bash probably. So yeah, let's talk about user input next. So user input, let's say that you want to enter something. So like, let's say, just, I don't know, enter something. And then the way you actually read the user input into a variable is use the read keyword, and then you just put in your variable. So like bar1, and then if you want to see it, let's just go ahead and say you entered, and then like bar1. So if you go ahead and do that, you enter clear. Oh, I guess let's enter clear, why not? So you enter clear, okay? So that is useful for that interactivity. So the two main ways that you can feed things to this is command line arguments or that sort of interactive input. Frankly, you're probably never going to be using the interactive input. It's probably all going to be command line arguments or hard-coded, at least for Bash scripting, to be honest with you. But it's good to know. It's good to know for like testing or something. So that kind of concludes the variables. So now we start talking about the if statement, which is where things get kind of interesting. So the first thing about the if statement that kind of really throws me out is that normally, in just about every other programming language that I am familiar with, when you say something like if true, then the statement here is the one that executes if this is true. And otherwise, this statement executes if false, right? This is not Bash, I'm just kind of writing here some text. So basically, if this is true, this executes. If this is false, this executes, right? If I go ahead and flip this around and I have a false statement here that evaluates to false, then this executes, right? Well, with Bash, that's not always the case. By default, actually, it's completely the opposite. So if I get something here that evaluates to false, then the if statement actually executes. And if it evaluates to true, then this executes. So it's literally backwards to like C++ or Python if statements, okay? So you might be asking like, why? What is this madness? Well, this madness is because we have to kind of analyze how Linux works. When you run a command in Linux, like when I go in and type in like ls or pwd or clear or just about any command in Linux, the command executes and returns a signal. And that signal is usually a 0 for a successful execution of a command. Or if there's an error, it's going to be something other than 0. By default, it's probably going to be 1, but you can be creative and have an error number be the return value, which can then be processed. Because of this, and because Bash is mostly meant to be a scripting language to kind of support running other things, because of that, the if statement evaluates to false is a good thing because it means the command ran correctly. Okay? So let's go ahead and see that in actual practice. This is very trippy. when you first see it. So like right now, you know, let me see what's in here. So we do have a folder called folder. It's a very creative name. And so let's just try to maneuver to that folder if it exists. And going back to the basics of how if statements work in Python, Python Bash, is you write the keyword if, then you put your condition, and then, you know, whereas in other languages you might use curly braces or you might use tabulation like Python for spacing things out, here you're going to be using the word then, and then you put your statement, and then you use the phi, which is kind of the backwards of if, to indicate the end of the if statement. And if you're familiar with programming, it's to solve the dangling else problem if you didn't have that in there. So let's go ahead and echo here something saying folder exists and it contains. So let's see what it contains by calling a command. Why don't we just do ls-li. Okay? So what this is going to be doing is if this command executes successfully, then it means that such a folder exists, so we can kind of see what's in the folder, because this will actually make us move to that folder. Okay? So let's try to run it and see what happens. All right, so we get a thing that says folder exists and it contains, and then we get basically what ls would give us, which is that, well, ls-i would give us, which is the details of the file in there and whatnot. Okay? So let's try to do this with a folder called folders, which we know does not exist. In this case, we just get an error that says no such file or directory, and of course, the if statement does not go in, so you don't get this, okay? So, you might still not believe me that a success is giving us a 0, and a failure is giving us a 1, right? It's possible. So, let's try a couple of things. This I didn't try on my own, but now I'm curious. Let's just say, what happens if you do something like this? Oh, well, we gotta get rid of the folder thing, or at least switch it back to folder. Oh, gotta finish my statement with a phi. There we go. So that works. So let me get rid of this. Let me get rid of the top one so you can see better. Actually, no, I'll leave that in there for now. But yeah, let's look at this. Okay, so let's see what I did in my if statement. Okay, I went ahead and said if1, just if1, which typically any programming language would pretty much evaluate true, right? So we would get this. But look at this, we actually got the else section, we got the end. So hopefully now you believe me that it's totally flipped. Like literally it's flipped. Like if I go and put in the 0 here, then you'd expect to get the end. But on the other hand, oh, it doesn't like 0 at all. Let's do 0. Can we do 0 here? I don't know if there's a keyword for false in this. We would have to give it a way of giving it a 0 for success, which I'm not sure, but you'll see it in a minute here, okay? You have just believe me in this, that if you just do your if statement like this, you are going to run into this issue where it's backwards, okay? So this is the reason why we have to have all these weird syntax for if statements to work the way they work in other programming languages, okay? But first, let's try a couple of different other commands that we can do in an if statement, okay? So, or checks that we can do, sorry. So suppose that we would like to search for a file, okay? So we're gonna say enter file name to search for, okay? So we're gonna read that into a variable called file. And now we're gonna use these square brackets to check for the file. But now, what are we checking in the file? Well, this command means to check whether such a file name exists or not in the current directory. There's a couple of others like this. There's D to check for if a directory exists. There's this one that we're doing, which is for checking for a file. This one's for a directory. There's also R that checks whether a file is readable. We can also do, they're all dash, not equals. Dash W to see whether it's writable. And finally, there's also X, which is for executable. So we can check all of these by putting it in front of the file name like this. And now in this case, we have to put 2 square brackets and we have to space things out kind of just like this. Okay? We have our if then phi, and then we can put whatever we want in here. So we're going to say if the file exists, then we're going to say file exists. Alternatively, we can have an else clause to our if statement, which is what evaluates when things go to false or true, depending on how you think about it. And in this case, we're going to say, nope, it does not exist. Okay? So if we run this, we're going to look for a file. A file.txt exists. Does it exist? Well, we can take a look for ourselves and see. And there it is. It does indeed exist. But it does exist inside the folder directory, right? Well, why did it show up? Because we have still the if statement up here that goes to folder. If we get rid of this, or if we just change the file name that we're looking for, then it will not find it. So let's say we're looking for potato instead. Then it says, nope, does not exist. Okay, actually in this case, I forgot the echo, so that's why it said command not found. But if I put that in, then you would see it. Nope, it does not exist. Okay, so that is going to be your basic checking whether a file exists. You can do this again with a directory, so let's try that. Although in this case, we are going to have to make sure it doesn't go into the folder first. And by the way, here's something to notice. I am running the CD folder, which would change me the active directories, right? However, that's only while the script is running. When that finishes, I'm back to my directory where I started from. That's kind of an important thing to understand with the scripting. That it's not going to permanently change it in your terminal. It's just going to be for the duration of the script, and then everything is back to the way it was when you started. It's by design that way. That's why I don't have to like keep backing out every time I run the script. So in this case, the folder I'm looking for is folder. Folder exists. Let's try to look for a different folder called folders. Nope, it does not exist. So it worked for that. Okay, let's try it with the executable flag. So in this case, we know for a fact that this is executable because we've been running it, right? It's called bash1. So if we try to look for that, let me bring it up to the top. bash1.sh, bash1.sh exists. Let's try bash. Bash does not exist. Okay? So in this case, oh, well, it says it exists, but it's really checking for whether it's executable or not. So it says that this is executable, whereas it's not executable because it doesn't exist. But if we test it on something that's not executable, such as file.txt, it says that it does not exist, which is what we have in the case where this is valid to false because it's not executable. So this is indeed checking whether something is executable or not. And it's just checking the permissions of the file, basically. If we change that, so right now we run it again. On file.txt, it still says it does not exist, right? Let's go ahead and do chmod plus x of file.txt. Let's run that again now, file.txt. Now it says it exists, which is the option that we have when something's executable. So that works indeed. Let's get rid of the, and we can see that too by doing the dash L with the ls command that it is not executable. Let's get rid of that though, because I don't want to accidentally do something bad. So if we do that, we remove the executableness of the file. So if you were to run it one more time, this time it goes back to saying that it is not executable. Okay? So those are useful whenever we want to check whether something is executable or not. And it's also a good example of an if statement. Okay? So if you ever want to just echo, I had this as a comment, so it might be useful to show you. If you ever just want to echo a command, you can, of course, just go ahead and do something like this. That will also work, as you can see there. Okay? So let's talk a little bit about comparing values. And by values, I mean what consists of variables. So we can use that same syntax with the square brackets, but things get a little bit interesting here. So first of all, let me go ahead and copy these three variables that I've made ahead of time. We have math A, math B, and math C. A has an 8, B has a 12, and C has a 3. Okay? So let us go ahead and write an if statement that compares whether they're equal or not. One of the ways that we can do that, and I am going to intentionally do some things here so you can see some nastiness. So I'm going to compare A and B. Okay? And now you will notice that I'm using this dash EQ. That stands for equals. This is one of the ways that you can compare variables. There's also other shortcuts like LT, GT, which is less than, greater than, and so on. So there's different ones for the ones that you would expect. But let's start out with just equals for now. So if they're equal, then we want to print out the word equals. Otherwise, let's check if it's less than. So I haven't brought this up yet, but yes, you can have else if. So we can have if else statements in Bash. You use elif, just like you would in Python. Okay, so in this case, we're going to write basically the same thing, but in this case, we're going to say it's going to be less than. So in this case, we're going to say math A is less than math B. Oh, and then whenever you do the else if part, so usually the then comes after the if, right? But with the else if, you also have to put a then. So you actually have to put it in before the statement, so like that. However, when you do your else clause, you do not need to put a then at the end after that, but you need to put the phi at the end of the if statement. Okay, so it's interesting sort of rules that you have to follow along to get this going. Okay. Oh yeah, good point, good catch. Thanks. Yes, that would have broken it. Thank you. All right. So finally, so we check whether they're equal, whether it's less than, which means that if both of those are valid to false, then it has to be greater than. Okay, so we go ahead and run this. We get that 8 is less than 12. Okay, seems legit. All right, let's go ahead and kind of try something else. Let's try switching this to 80. 80 is greater than 12. Okay, that seems to be working. And then we can try 12 just to see if that equality works. There indeed equals. Okay, so this seems to be a good way of doing comparisons between the value of a variable. Okay? So this is where things can go bad. Go ahead and copy and paste this. Maybe I'll do like something to separate. And so the other way that you could compare things like this is using your old school symbols, like equality like this, or less than or greater than, like you would in the languages, right? Okay, let's try to run it and see what happens. You get, in the first one, which we did before, which we know works, yeah, we get 8 is less than 12. However, on the second one, we get that 8 is greater than 12. So, does anybody have an idea as to what is happening on this one? Well, it's not surprising if you know what's happening. Turns out that when you're doing these, it's counterintuitive for sure, but what it turns out is happening is that when you're using your conditionals with the old school symbols, what it's comparing, it's doing an ASCII string comparison. Because as an ASCII string comparison, you know, when you're comparing things with ASCII, you know, you have two strings, like let's say we have Sally and then we have Sam. It compares the first character of both, ASCII-wise. If it's equal, it keeps going. Then it compares the A's. They're also equals. Then it compares the L and the M. In this case, the L is smaller than the M because in the ASCII table it shows up with a smaller number, so that it'll say that that number is smaller per se. Things get even more messy when you talk about uppercase and lowercase, because in the ASCII table, I believe the lowercase come after the uppercase, so then you could end up saying something like Z is lower than A. Okay? And so when we look at that, and we analyze this, then we can see that the ASCII of the 8, you know, compared to the ASCII of the 12, well, it's looking at 8 and 1. So, of course, 1 is going to be smaller than 8 ASCII-wise, which is why we are getting that 8 is greater than 12. Because the 8 is comparing the 8 and the 1. It's not looking even at the 2 from 12. It's just looking at the 1 and the 8. And it sees that the 1 is basically smaller and the 8 is bigger. So it says 8 is greater than 12. So, the moral of the story is that you have to be very careful when you're using the if statement with these symbols, because it's not going to be comparing it with the value of the number. It's going to be comparing with the ASCII of that. Okay? So, what if you're insistent upon using the equal signs because you don't want to use these weird, nasty things, which, you know, I feel that. Okay. Well, there's another way that you can do this, where you can have your cake, I suppose. In this scenario, instead of using the square brackets, we use parentheses. And if we use parentheses, guess what? It gets even weirder. We don't have to even use the dollar symbols. And if we do that, then things should work properly. Again. So we can see all three scenarios. We got the original one, the one that doesn't work because it's the string comparisons, the ASCII value comparisons, and then with the third new method, which shows that it's back to working again. We can test it with other numbers. Let's test one that would work in all scenarios, which would be like a single character. That would work in all scenarios. The 1 is less than 8, right? But then if we do something like this, then we get 10 is greater than 8, 10 is less than 8, 10 is greater than 8, because again, this ASCII thing doesn't work out, right? So this is if you really want to use your old school symbols. You have to use the double parentheses. Both of these kind of fix the issue with the if statement being backwards, because when you use the parentheses, it like flips the logic, so it's back to the old school way that we know it. So yeah. Going back to the whole 0 and 1, I had another example to show you. Let me just copy and paste that. Let me get rid of these. Again, I can share all of that later on. So I have an example here where I'm just using the ls command, okay? And I did notice that I don't have space here. So in one scenario, I am running ls with the parentheses, and another one I'm running with the square brackets. Let's just see what happens when I run this. One of them returns false, the other one returns true. So the first one gets false, The second one gets true. So here's what's happening. Again, by default, all Linux commands, when they succeed, they give you a 0 as a success command. The parentheses in Python are evaluating this as a numerical expression, so it's keeping the fact that it's a 0. Which is why, when this is 0, it's going here. However, on the second one, this is more of the original bash way, where this is returning a 0, but yet it's returning true. You see that? So in this method, 0, because both of these are returning a 0. Like ls is returning 0. But in this system, the 0, it's happy to take it as a true statement. And here the 0 is taking it as a false statement. This is the traditional way of other programming languages, where a 0 will give you false. This is the bash way, where a 0 will give you true. So that's where the big sort of thing that you guys have to make sure you don't screw up. And that's what we probably ended up screwing up the first time we tried bash with this thing. That, again, the default bash behavior is that an if statement that evaluates to false, that's like the true part of the statement. So like an if statement that evaluates to false is going to go there. An if statement that evaluates to true is going to go here, which is the complete opposite of other programming languages. Okay? Down here, the ls command returns a 0 because it succeeded. Therefore, because this is returning, the if statement is evaluating to false, you're getting a true there. That's where we're getting this true. However, whenever you want the if statement in bash to work the traditional way, where if true gets you true and false gets you false, the way it should be, you use a parentheses. And that sort of flips the logic in the system, okay? Any questions about that? That's frankly, when I was looking at this, the hardest part for me to like comprehend that this was working this way. Because it just not feel intuitive at all. Like not at all. But that's just the way it is. So I hear silence, so maybe you guys get it better than I do. That's good. All right. So now let's confuse you more by showing you some fancy shortcuts for if statements. Yeah, go ahead. Yeah, just double brackets. Are you running it on Kali or is it a different distro? Oh boy. Did you put the spaces? You have to be very careful with the spaces. Nicholas says that when he runs a single bracket, it works as well. See, that's probably the whole bash versus like Z-bash issue that we were having the other day. Yeah, the ZSH. Z-shell. Let me try one and see if mine works with one. Yeah, mine works with one. So shall we just go with one? That seems to be the more reliable, yeah. Oh, what about this one? What if we throw one on this one? I don't think that one's gonna like it. Oh, that switched that to true. So that broke that. So this one has to be 2. Otherwise bad things happen. Yeah. But one runs, but it flips the logic, which is even worse. So yeah. Yeah, basically double parentheses is flipping the logic to what a normal human being would understand an if statement to be like, instead of the bash programmer statement. All right, okay, that's good to know. So yeah, so go with single square brackets versus square brackets if you guys have issues. Yeah. All right, let's see how these work out for you guys. The next part of this, which is the if statement shortcuts. So whenever you just want to make your code more confusing, you can go ahead and do some shortcuts. So I'll leave this as reference down here. Suppose that I wanted to make this with less text, because less text is always better, right? Not really, but let's go ahead and say we're going to make a variable. We're going to call it my command, and we're going to put in something that's not going to work, such as cd potato, because we don't have a folder called potato. So that doesn't exist. So that should throw an error. So what if I wanted to do that using this system? Well, we can go ahead and switch these to say my CMD. I think this one you put a $, but this one you don't. Let's just try it and see. So syntax error. Line 12 and line 18. Okay. Okay, so you don't put the $sign on that one, but I guess you do it on this one. I think that's just not going to run it because it's trying to do a math expression, and it's a string, so it's confused. So let's just kind of ignore that one for a minute. Let's just talk about this one, okay? So this one is returning true. Okay? So why is it returning true? It shouldn't be returning false. Does this mess with it? Let's try that. Nope. Well, this is an error in the command, so it should give you some 1, which would then give it a false. Let's try another command. Let's try to do ls and see if that what that gets us. Still going for true. Okay, this broke. I think it needs a $sign. Yeah, I don't know why before it wasn't complaining. So, okay, so now if we go ahead and put a bat command in here. Okay, there we go. That's good. So I don't know why before without the $sign it was just happy, and at some point, yeah, okay. So yeah, $sign. So in this case, this command does not exist, or this folder doesn't exist, so the command returns a failure. So if I run this with a failure, such as it is now, we are getting the false line, okay? So if I switch this to a good command, we are getting the good command, okay? Now remember though, the good command means a 0, so it's still backwards. So it's not like it's fixed now, it's still backwards. Like we still got the backwards if statement, because this returns a 0, which is here. In fact, just to make it easier, we're gonna call it return 0, return non-zero. So right now, this is returning a 0, whereas the error one is returning a non-zero, okay? So the shorthand that you can do for this is you can say $myCMD colon and then another command. So in this case, like return 0. And if you do this, then if this command wait, I just want to check if does that make a difference? No, it doesn't. Okay, cool. So in this case, when you run this, you can see that you're getting a return 0 from this one, but you're getting a return non-zero from this one, right? So this is going for the I would say the first line. Although this doesn't feel right. Hold on, let me try something. I was gonna get to this later, but this might fix this issue if that's the issue. I don't know. I feel like this should return. This shouldn't be running. Let's try it like that. Well, okay. I'll tell you what it should do. Although I'm not sure if it's working the way that I expect it to. This is the if statement, and then this is what should run if it evaluates to true. However, here it just seems to be running nonstop. However, there's another one that I know for sure works okay. And this one is using the and the or that we're typically used to. This one will be good. Because this one, you just go ahead and put in like this. My CMD. So this is like, if this is true, or if this is 0, then this will run. And if this is 1, then this will run. Something like that. So if we, well, you can kind of see it here. So you can see the null right there. Okay. Now we get this no such file directory. That's just because the command actually failed. That's the error that you get. So just ignore those. But essentially, it's working correctly, because the yes doesn't work because it's an invalid command, because the folder doesn't exist. But the no does run because it's an invalid command. If I switch this to something valid, like cd folder, I think that's the name of the folder, then we're gonna get the yes from that. Is that the name of the folder? It's just folder. Yeah, I think we might need a /. I don't think that, or maybe it doesn't matter, but yeah, so we get that. Okay, so we get the yes. I can see the yes, but we're still getting that no, which I don't know. Let's get rid of that. Let's see if we get that. I don't like where we're getting that no there. That does not feel good. We'll switch it to a single line command. CD unary operator expected. Yeah, this one's doing weird things, but at least this one is working, because you can see CD folder is returning the yes, versus if we did CD folders, it will not return the yes, as you can see there. So at least that piece is working. Okay, so that's the shorthand for the if statements. That, again, you can just go with this one, which seems to be somewhat reliable, but there are these shorthands in case you run onto them. I have other examples here which were working, so let me just copy and paste them and see if they run. So I have comparing equality between 22 and 33, 22 and 22, 33 and 33, and 22 and 33, right? So basically, this is equal, and this is equal, and then these two are not equal, right? And so for the first two, I am using the AND, so that should return to me this one false, and this one true, because these are equal. And then here, the other way around, this one should print out, but this one shouldn't print out. And as you can see, if when I ran it, it did work. So there is my proof that when I was testing this earlier, it was working fine. But for some reason, with the other command, it seems to be doing weird things. Which I can't explain. But at least there, it's working with the numerical things. Maybe it's because I didn't put it in the square brackets. That could be it, actually. Yeah, that could actually been the reason why I was getting weird issues with the other one. Maybe if I put it in the square brackets, it will fix the problems. Nope, still getting weird things. Maybe put this like that. Nope, that just makes it worse. Yeah, I don't know what's up with that one. But at least with the other example, it seems to be going okay. And we could try to do the other way with the parentheses. This one I didn't test, but I presumed that it would work the same way. As you can see, it's saying that they're not equal, but if we switch this to that, then they are equal. And we should get that equal 4 print out, which we do. So you can use the parentheses instead of the square brackets. So mine worked until I got to equal for the double square brackets. Oh, so yours isn't working in this in the 4 examples here that I have, like the original ones? You're not getting the 2 and 3 printing out? You know, assuming that you guys, you know, that we do what we kind of agreed with the single bracket. Okay. I just don't know why it's not working with the other version. Let me just try and copy and paste the exact code that I tried earlier. Trying this. It's always running the ls command, I think. Seems to be. This should fail. But it is clearly running it afterwards. So I'm not sure why this shorthand isn't working. But anyways. Let me see what other examples I have. Oh, I had a representation of this. So just to make sure that you understand what is happening here, I went ahead and wrote the if statement equivalent of that here. So this is shorthand for this, right? Actually, technically speaking, that one is shorthand for the and one. So that would be, well, here, I have it here. That one, see? If we wanted to make this one into the if statement, we could do that. We could say if, and then just copy this thing. Then I guess else, and then phi, and then that would kind of technically be here. Oh, didn't copy it. There we go. I guess that would be kind of what it would look like. I mean, this is not exactly the best way that you should be doing an if statement in the first place. You know, you could probably use the not equals to flip the logic. This is one of those things that you should probably never do. Just leave it blank like that. But yeah. So okay. Here's more examples with the numbers, the parentheses. Actually, I guess I did have those. So here what I did was I was using parentheses with the numbers and doing some math. And then checking whether they're equal or not. So if I run that, you can see. Oh, no. I know why I did this. Yeah, okay. So this is where the curly brackets come into play. Okay. So notice something interesting here. So I am comparing whether 33 is equal to 33, which they should be equal, right? So I go ahead and run it, and it says, you know, if we comment out these other ones. Bring it up to the top. It says that here, let me get rid of these ones. It says that yes, they are equal. We can see the 1 there. I labeled 1, 2, 3, 4 so we can see them, okay? Okay, cool. Let's try it in a scenario where they are not equal. That one, okay? In this case, they're not equal, so I should not get anything to print out, right? But I still get they are equal to printing out, right? So if I comment the top one out, it's printing out they are equal. So it's not printing out the yes, but it's still printing out the yes, the they are equal part. Turns out that it's because the way that the syntax in Bash works is when you're doing this shorthanded if statement, only the next command right after is what is detected as inside the if statement. Anything after that is not part of the if statement. So if you want to put multiple commands inside of that if statement clause, you use the curly brackets for that. And that's kind of what I'm doing here. So that's the problem one, and then this is the solution to that. As you can see, I put the curly bracket instead of the first part of the statement, and then I close it with that. And I separate the commands with semicolons. And put a bunch of spaces everywhere, otherwise this thing gives you errors, basically. And so if I run that only on the right version, then I'll see that nothing prints out. That's a good thing because they are not equal in comparison to the bad version, which is the top one here, in which case I get that they are equal printing out. And then the same can be said for the other one, which is for the correct one. So in the correct one, I do want it to print out the yes, they are equals part. But then in this one, you will also see the fact that it says yes, they are equal. But really, it's because you are putting the curly brackets correctly that it is printing it right. If you didn't, then that would break it by printing that they are equal, even though they are. Well, no, that one they are both equal, but technically speaking, this is the right way to do it. Because otherwise, even if they weren't equal, this would print out. So like if this was 32, and then we comment this one out, then it shouldn't print out, but it is printing out, right? And that's because we don't have the curly brackets in there. Add the curly brackets in, and then nothing will print out. So yeah, that's actually why I had that example. Just to show you how to use those curly brackets, okay? Another thing that at this point I was like, oh, it's kind of a good thing to know is how to use the exit command. So if you want to terminate your script early or just at any point before the end of the actual code, you can use the exit just like you can in Python, except in Python it's exit with parentheses. Here it's just exit. And if I have code like this, I should not see the after exit print out because it's going to exit beforehand. As you can see, that is working. I get the before exit, but not the after exit. Okay, let's go into looping now. All right, so with looping, I discovered a couple of different ways to do loops that are interesting to see. Let's start out with the most basic of the loops, which is the while loop. And then it turns out that, again, when you're coding in Python, you know, spacing is what makes the loop, what's in the loop and what's outside. With something like C++, it's the curly braces. When it comes to Bash, you use two keywords. You use the do and then the done. And that's kind of what would be the equivalent of your curly braces that you're replacing. And then the loop code goes inside. So suppose we want to make a little loop that prints out a bunch of numbers repeatedly or something. So let's create a variable that's going to be kind of like your iterator variable. And then let's go ahead and do something like while I is less than 4. And then go ahead and just print out like I. And then I++ so that it increases every time. I am using this little keyword here that you're looking at called let. It's one way to update a variable. You could also do it like the other way, which would be something like this. So instead of doing this, you could say something like I equals. Well, you can't do j+1. Weird things will happen there. So you are going to have to put a $sign here, and then the the arithmetic expression parentheses. I think that's the official name of them. And then do the I+1 inside. Like that. That will work okay. Less writing. Kind of more readable than this too. But yeah. So anyways, both of these are basically just little loops that's going to loop and print out a number as it increases. 0, 1, 2, 3. Again, 0, 1, 2, 3. So both do the same thing. Just a different way of updating that variable. So yes, whenever you want to update variables, you have to be careful how this is doing it, because you need to turn it into an expression if it's a number that you're trying to update, so that you can do the math correctly. So, and again, up here I'm using the double parentheses because again, this is a conditional that I'm trying to get the conditional to work. I guess I didn't try this, but I'm assuming it'll work. I can use these things as long as I switch this to less than, and I put a $sign there, and that should work the same. Yep, it works the same. So there's that. What you don't want to do is you don't want to switch this like this, but still keep the less than, because again, that's doing the string comparison, which might actually work here. But yeah, it worked here because of the string comparison being okay, but you could break this super easily. Let's just say that I is, well, let's start with a negative. That's probably gonna break it. Yep, that just didn't run at all. Which it should have kept. It should have run multiple times. In fact, if I switch this to less than, you will see that it would run like -5, 4, 3, 2, 1, 0, 1, 2, 3. So you can see that the logic is messed up because the negative is not less than, the minus symbol is not less than the 4. Or vice versa. If we make this like a 20 and we say I is less than 1, technically speaking, this should not run, and it will not run. However, it's wrong because it's comparing the 2 and the 1. So if I say something like, yeah, this is a good one. So if I say I is 20 and then I say I is less than 8, the problem here is that it's comparing the ASCII 2 to the 8, which means that 2 is less than 8, so this is going to run even though it shouldn't, because 20 is not less than 8. So bam, you see it run tons of times. Okay, so again, the reason why that's running a lot is because it's doing string comparison of the first character, which is a 2, with the 8. So this is, or it's going all the way from 20 all the way to like 80, which is when finally that stops. That's why you see this go all the way to, well, 79. So that's because it's doing string comparison. So you either use this thing like this to fix that issue, or you use the parentheses like I do down here. Okay, so but just be careful about that scenario of using the, you know, the typical symbols like equal, equals, or less than, and using the square brackets. Okay, so just be warned about that potential risk. Okay. If you want to know more information about this whole lab versus arithmetic expression, your best bet is just to Google. It gets really complicated, and I really didn't want to go too deep into it. Yeah, we'll just go with that, because I mean, yes, these two things do the same thing, but like there's times where one's better than the other and things like that, and it can get really, really, really nasty. So yeah. Anyways, that's how you do the basic loops. Again, I would stick to the bottom one here. Oh, I minimize. I would stick to this bottom version and not use ever these, but yeah, if you really want to, you can. Let's talk about other scenarios, which is the for loop. So this time I went really deep and saw a bunch of different cool ways of using a for loop. So I'm going to show you a couple. Let's start with the basic for loop, which we tried to do the other time and failed. So what you do is you use the parentheses again so that you can do all your math properly. and then you can have your post increments like this. Then put your do, then whatever you want to do in the loop, and then you're done. Literally, you're done. Okay, and then here we go, 0 to 5. So you could also do something like, if you want to do more than one increment of just not just one, but like +2, for example, instead of +1, you could do something like this. And you don't need any dollar signs or anything. It'll work fine either way. So you can see there it goes from 0 to 2 to 4. No 6 because 6 is greater than 5, so it never gets to the 6. But yeah, you can do any increments here. You could do decrements as well. So let's say we start out with 10. I want to say I is greater than 6. So you should get 10, 8, and then not 6, right? Let's do 5 so we can see at least one more number there. There we go. So I don't know if this for loop you can change to the square brackets. I would not want to. Don't try it, basically. But I guess in the name of science, if you want to, you can. But I'm not going to try it. For the next example that I'm going to show you, first I want to show you what this special command does, is Arg command. So let's just echo Arg and see what happens in this version. We just get Arg. Okay, well, let's put a $sign and see if it changes things. We get nothing. Okay, that's better, I suppose. Yeah, I guess. All right. That should print out the commands, but it's not printing them. But let's put it in a loop and see if it works there. Because I did try it earlier and it was printing commands out. Now it works. Okay, interesting. So arg is a little shortcut in bash to be able to print out the command arguments yet again, like $1, $2. If you want to print them out in like an array format or list format, I suppose. I don't know why when you say echo alone, it doesn't like printing it. You have to iterate through it. So you can do that. So this is a lot like the Python for loop, like for X and I kind of for loop. That's kind of what's happening here. In fact, my next example is doing that. So like, let's say we have we have an iterator with like an item, and then we say for item in, and if we had a list, we could put it here, but we're just gonna make one. So like Mary had a little lamb or something. Okay? And if we do that, then we can say something like echo token and then item. And if we do that, it's literally going to print out each of these one at a time. So like Mary had a little lamb. Okay? But the word token just means like word, but it's just the word word instead. It's not anything. So, or you could just print out just flat out. Actually, can you do like that? Yeah, you don't even need the quotes in that case when you don't have any strings with it. So that's cool. I didn't know that actually until I saw it earlier. I don't think I ever tried that. So this makes me feel happier because this is like Python territory that you can do this. You can get even fancier with this. The first thing I did when I saw this is like, how hardcore can we go with this? And so it turns out you can go pretty interesting with this. So I have a little file here called file.txt that I was messing with earlier. That file has some text that says, hello world, this is a file. So suppose that we want to iterate through each of the words in that file, right? Can we do that? Well, yes, we can. So you can use your for word in, and then what you're going to do here is you're going to capture the data from that file, sending a command. Remember, we can send commands by saying something like $ and then putting the command that we want to do, right? So like my command equals $, and then I do like ls, and then I echo my command. Then if I run it, I should get the concept of, whatever ls returns, right? So I can combine that and I can put that in here. But instead of ls, you know, something more interesting. Although you could iterate with ls all the file names. Not that I think about it. That could be kind of cool too. Let's go ahead and use cat on the file. Like that. And bam, now you have access to the file on each of the words in the file. So you can say like echo, and then be like word, and then done. And if I run this, well, I still got the Mary got a, oh, because I still have the top one. Well, ignore the Mary had a little lamp part, but you can see here it says hello world, this is a file. That's pretty cool. And then since I just thought about that as we were trying to do this one, you can do this with ls as well to iterate through all of the files in your current directory. As you can see there, we have files and folders, I guess, in this case. Since we have file, we have backup, which is a folder, we have bash, which is a file, file1, which is a file, and then folder, which is a folder. So you can iterate through both folders and files in this scenario, right? The point is that you can do through anything. Whatever if you can pipe it, you can use it in this, essentially. So that's pretty cool too. You can also combine different sources of things. So like another thing that I discovered that you can do is kind of like a range-based for loop in Python, sorry, in Bash. But here what I did is I have still the command, the ls command, but then I added some numbers to also run through. So it's still running through the files inside of the directory, these 4 files here, but it's also running through these numbers. So let's kind of split that example into its own thing. So range-based for loops in Python are where you say something like for x in range, and then you do like, well, if you do 6, it goes from 0 to 5, but you can also do something like 4 to 10, and then that goes from 5 to 9, and then you can also have a step thing. So that's Python, right? Well, you can kind of mimic that in Bash, and the way you do that is you say like for I in, and then you put your curly braces, and then you put the range of numbers there. But you put it in a kind of an interesting way. You put like I said, like 2 dot and like 5, but this is inclusive of the range, I believe. So, you know, if we, let's print them out so we can see it. If it is, it's not actually. Range-based, $I, done. Let's get rid of all of these for now. Like I said, I have a file with all of this stuff if you guys want. You can see it goes 2, 3, 4, 5. So most of the times, at least in Python, it's when you do range-based for loops, it doesn't include the last number, right? If you do, like I said, 0 to 5 or just length of something like 5, it goes from 0 to 4. Here, it does not. It includes that last value. It includes the first and last value. It's inclusive. You have to be careful about that if you're iterating through like some sort of data where like, you know, counts from 0, you don't go 1 extra. So that's the only catch with this. But this can get really cool though, because you don't, you know, yes, you could do something like 20 through 55 and it'll get that. But what you can also do is you can do some fancy stuff. Like, let's say go from 10 to 25. But notice that I put a 0 in front of that. It actually puts a 0. It pats things. That's not something I'd seen before. Not sure what you want to use that. Maybe when you're doing some file name convention stuff, that you're making a script to like rename files or something. But it does pat it, so that was kind of neat. I was like, oh, that's pretty neat, you know. You can do something like this. It'll pad everything, so that's pretty cool. I wonder what happens if you do it like that. It still pats it. So as long as one of the two has it, what if I do it like this? Still pats it. So yeah. So as long as one of the two has padding, it'll pad both. It'll pad it continuously the same way. So the trick is just put 2 dots and then put the curly brackets. All right, that's pretty much it for loops. So last thing, and then we're good to go, is going to be functions. And with functions, there's a lot, so we're only going to do some stuff. Let's start out with the most basics. How to write a function, I suppose. Well, let's write it the way that you would want to write a function. So let's say function foo, and then, you know, we're in foo. So this is a good example of a function. However, as you're going to see in a minute, there's some things here that I'm putting that you don't technically need, but I would encourage you to put them just to make it more readable, okay? But if you want to call the function, you just type the function name and you're good to go. So as you can see, it's running the function. A couple of things you can do here to make it nicer. I mean, I like to code this way with the bracket on the last line, but it doesn't really matter much. But the other thing is, you technically only need either the word function or the parentheses. You don't need both. You can have both, but it's kind of redundant. So like if I remove that flat out, this will work the same way. And I believe vice versa. If I remove this, it'll work the same way. Now if I remove both, it breaks, yes. So you need one or the other. But you can have both too. Frankly, this is what the book said too, put both, because it's bad enough it's as unreadable as bash is. You know, you don't want to make it worse. So this kind of gives it some sense of readability to see the word function in there and the parentheses. So there's that in its defense. But yes, that is how you basically do a simple function. One of the big things that you should be aware of when it comes to functions in bash is scoping. So there's two sort of main approaches to scoping when it comes to functions and programming languages. We have things like C++, where each function is its own scope. And if I call a function that is like, you know, if we're looking at a program, C++ program, you know, you got your main. And if your main calls foo, and foo calls bar, and there's some variables also in the global scope. Let's say there's v in global scope. If we're inside of foo, and it doesn't find a variable in that scope, it can go out to the global scope, right? If we're in bar, which was called by foo, which was called by main, if we're in bar, and we don't find the variable, it doesn't try to check it in foo or main, it just goes straight to the global scope. Now within the function, if in C++ or some languages like that, if the function has curly brackets like this, they are their own scope. So like if you have a for loop in here and that's inside a while loop and so on, it checks the scope first, then the scope, then the scope, then the scope, then the whole function scope, like parameters and whatnot, and then the global scope, right? That's the traditional way in something like C++. JavaScript, on the other hand, it's a little different. JavaScript, if you have the architecture or hierarchy, sorry, if you have this hierarchy that like a function calls a function and a function, it looks in this body first to see if the variable is there, but then it looks at the call stack. So it looks at who called this function, so in this case foo, and it checks if the variable exists there. If it doesn't, then it goes back and sees who called foo, this main function, and then if it doesn't, then it looks in this global scope. That's a little bit more complicated because like it's really hard to predict how you got to a function at runtime. So like what you may assume is reaching to the global scope may not be reaching to the global scope because it's reaching to another function. It can get pretty nasty, right? So that's why people are like, ooh, JavaScript, you know, cringe. So typically it's something like C++, that system is better, right? All right, so that brings us to bash. So which of the two do you guys think that bash follows? Well, it turns out it's neither. Bash just YOLOs it. There's no such thing as scope in bash. Bash is just like whatever. It's all global scope to me. Bash does not respect the fact that you're in a function. It'll just reach to the global scope like nothing. To show you, I kind of came up with a little example of that. So let's go ahead and put it. Let's make a global variable. Call it bar1. You know, put 55 in that. So my function foo, you know, normally, okay, if I have a function like this, and then in here I have something like let bar1 plus plus, you know, yes, I'd expect this to reach the global scope because it's not within the local function scope, right? So if I go ahead and run something like this, and then I echo bar1, then I expect there to have a 57 because it incremented it twice. The first time with the first function call, the second time with the second function call. Nothing surprising there. Same thing would have happened in JavaScript or C++. However, let's go ahead and throw in a local variable, or what we think is a local variable. Bar1, another bar1. We happen to choose the same name because we can. I could do that in C++. In fact, you do it all the time when you're doing something like a for loop, right? We use variables all the time that we've used in other levels of scope. Okay, so normal me is like, okay, you know, if I go ahead and echo in here in this function, you know, what bar1 contains, I expect bar1 to contain a 34, and then the next time it runs, it contains a 34. However, this bar1 is referring to this one and not to the local bar1, so this should still print out 55. So I run it, and I get 34, 34, 34. That's when you're like, ooh, this is not good. Because, first of all, just for starters, the first time it sees this line of code inside the function, it's just smashing that 55 and replacing it with a 33. That 55 is gone forever. So it does not respect scoping. It just goes for it. So after that, well, it replaces the 33 with a 34. So we get a 34 printed out. Function ends. At that point, this 55 is gone. Now there's a 34 in there. Next time it runs, it replaces it again with a 33, and then you get 34, so you get a second 34. Finally, when this one comes out, it's looking at this bar1, which has been destroyed by the other two to 34, so that's why you get 3 34s. This will not happen in C++ or Java or pretty much any other language that doesn't do this nastiness. So, yeah. Be very, very careful about this because this can ruin your day when it comes to debugging. So, yeah, that's my forewarning about that. That is definitely not something nice. So, moving on from that, other things that are useful to have in functions is parameters, right? Like, how do we pass things into functions? I mean, sure, everything is global, so like you could just pass it globally, I suppose. But suppose you actually wanted to pass parameters and try to be a good programmer and whatnot. Well, you can do that by kind of using the same syntax that you were using with the command arguments with the $1s and $2s. So if you have parameters in a function, you can look at those by using the $1 and something like $2. And those will be the first and second parameters passed into your function. Okay? Now, how you pass them to the function? Normally, some languages, you know, you do something like this, right? You'd be good to go. Not in Bash. Not in Bash. In Bash, you just kind of put them here next to the command, basically. So you can say something like hello, and you put like 2, just flat out. Actually, heck, let's just make that be a number like that. Okay, and then maybe the second time, we can pass in 2 strings. This time, hello world. Word. And then maybe like a third time like this, okay? And then, well, let's do the echo 55, and this time it's not broken. So this time you can see hello and 2, hello and world, 2 and 4, and then the 55. So as you can see, the ordering is fine. Suppose that I call it one more time without anything. Is it gonna crash? Is it gonna run? It just runs. It doesn't care. I guess that's one thing it has going for it, that it will not crash if the parameters are being used but they were never passed. So, you know, C++ would crash. Python would give you a traceback error. So I guess, you know, on one hand you have terrible scoping rules, on the other hand you have no errors when something happens. So yeah. So yeah, that's basically how you pass parameters. Other big thing that could be useful to us is how to return things from the functions, right? So like a value returning function per se. Oh, and by the way, just to show you that again, this thing doesn't matter. We can get rid of this foo part. The thing will run fine. And then you can also get rid of this part, and this will run fine as well. As you can see, again, they're mostly just for shows. In fact, you know, you might have thought that we were going to put the parameters in there like any other language. No, this literally just kind of to make it look pretty and whatnot. It has no functional use other than telling it to function. So I wouldn't blame you too much if you do your functions like this, but I still think that both is better. Okay. Yeah, go ahead. Yeah, that's a really, really good question, actually, because I thought that too, and I was like, ooh. So yeah, it turns out that those are gone forever. So if you don't want to lose them, before you ever pass a function in, you want to make sure you save it to another variable. So like, suppose that we are we running this with A1, A2, A3? Yeah. So if you want to back those up, what you have to do is like, you know, create a function and like store them like this. You can probably make some sort of list, but yeah, something like this. That way, whenever it's back, then you still have a way of accessing them. You know. Let's do different names for them. But yes, you will lose access to them. It's a big back thing, so you can see it there. A1. I don't think you can reset it. Like you can't set it back. I think I tried that earlier and I had an error, but let me try it again. I think it was complaining about that. Yeah. It replaces it to this command. Actually, maybe if I do it like this. A1 command off. No, because it's substituting this with the A1. So I don't think there's a way to set them back. You just have to save them to some temporary variables. At least that's what I saw online, because I googled that too, and it just said back them up to somewhere else. But yeah, you're absolutely right in the sense that they're gone if you don't save them. They're gone forever. I think I forgot the issue with the CD not working. It looks like it needs the full path and not a partial path. CD home. Oh, maybe. Yeah, that would make sense actually. Although I was able to maneuver between folders, I'll have to check that out again with the CD thing. But that's definitely a good point. That might just be the path issue. So, yeah. But anyways, so I'm glad you brought that up actually, because I did want to bring that up as well. So cool. Let me show you function. How to return variables from functions, and then we'll be done with all the bash stuff that I have prepared. So the way you do that, let's just make another function. Let's just say you're doing some math, so let's just make a variable here where we, you know, add like 4 to whatever you passed in, the argument you pass in. Okay, so this is taking the parameter you pass in and adding, I guess, 41 to that, and then that's saving it into var1. And so then you just return that var1. I don't know if you, I mean, I'll try it in a second to try to combine this into a single line. I never actually tried that before. But anyways, once you do that, what you do is you just pass in your argument. So let's say we're adding in 10, and maybe we're gonna do 2. And then let's echo. Oh yeah, so this is kind of interesting. So the way you get the value back that you've returned is not intuitive at all. You use a question mark, a dollar question mark. So yes, the value returned is, yeah, so I think by default it's 1. Maybe if you have a way of returning like a list or something, but at least what I saw is that yes, you're limited to 1 return. Yeah. And $1 is that. Okay. And maybe the second one we just do. Because I don't know why they chose the question mark. It's just to make it interesting. They were bored probably. So there you go. Valid return 1 is 51. So 10 plus 41 is 51. And then for the other one, I guess 41 plus 3 plus 2 is 43. So, and yes, there's another escape sequence just to refresh you on that. But let me try. I want to see if this would work. I can just put that in directly here. Ah, that works. Cool. So you can do the inline assignment. So, like other languages you would. Okay. But yeah, if you have some sort of data structure that can return a list, then I guess that would be one way around this. But if not, then yeah, stuck to one thing. So that pretty much covers most of what you would need to kind of get going on a script. I mean, you got if statements, loops, functions for when you want to do things kind of repetitive, and if for loop is not enough, variables, interactive input, output, and some string and comparisons. Really, I don't know if there's anything else that you need, but I mean, I'll think about it. I'll take a look at the book. I think from here they just start talking about regular expressions and other fancy things. But bash itself, this is a pretty good introduction into being able to do as much as you ever need to do with scripting. From maybe 80% of what I gave that actually worked, because the other 20%, like the whole CD thing and the short if statements, were kind of glitching out on me. But we got through most of that. So, any questions? All right, well, I'm gonna stop the recording since that was a big thing for today, was the bash.